Now, let's talk about the different commonly used measures of location. So, first we will be dealing with arithmetic mean, then we will talk about median, and then the mode, and the fourth one that I would like to cover here is the mid-range. So, these are the most commonly used measures of location. And whenever I'm talking about any measure of location, it is one single value. I'm trying to compute one single value which tries to represent the center of the data, right? So all these four are different ways of arriving at the center of the data. Whatever the data set that I am provided, they are going to give me the center of our data. We generally use the word average as a proxy for the center. And in many cases in our daily lives, we use this word average. And this average or the centeredness of the data is computed by generally by one of these four different mechanisms. And okay, so what we will do is we'll take one data set and we'll try to do all these four computations on this data set. Try to understand how each of them are differing in their process. Arithmetic mean. We know it is nothing but sum of all observations, whatever are given to me, divided by the total number of observations. It's a straightforward concept. And if I'm doing this for a population, I say that the arithmetic mean is represented by mu, where sum of all the data of the population divided by the total number of elements in the population. But if the same thing, if I am doing it for a sample, I denote it by x bar. So it is nothing but if I am assuming that x1, x2, x3, so on, xn are the different elements of the data, summation of all the elements, right? Summation of all the elements divided by entire population. Generally, when I use capital N, I call it as the entire population. So this gives me the population mean, which is mu. But if I am doing the summation of all these observations, dividing by the total number of elements in the sample, then the same is being called as the sample mean, which is denoted by x bar, right? So the formula is more or less the same. It's that I divide by the total population size for getting a population parameter. I divide it by the total sample size to get the sample mean. And frankly speaking, I can take the help of Excel sheet for doing a lot of these calculations. So here, if you look at, I have collected the monthly returns of Sensex from May 2012 to, let's say, April 2015. So over a 3-year period, we are talking about the monthly returns of the Sensex data. And I really wanted to find out what is the typical arithmetic mean of this particular data, arithmetic mean return. And when I'm saying arithmetic mean return, it's the summation of all these things divided by the total. So just to showcase that, I'll say I'll do a summation of all these values and I'll divide by the total number of observations, which will give me that it's around 1.23%, right? That is the arithmetic mean. And I can compute the same arithmetic mean using a formula called average in Excel, which should give me the similar kind of answer. So going theoretically, it is nothing but sum of the observations divided by the total number of observations. So either I can do that or I can simply use the formula average. Now, let's try to understand one of the important properties of this arithmetic mean. What I'll do is, I'll try to subtract this mean value from each and every observation. So I'll call it as x minus mean. So from each and every, so here, so this number minus the mean. So I'm subtracting the mean from each and every observation. Right? I have subtracted from 7.2, I'm subtracting 1.23%. So from the mean, I'm subtracting each and every observation across. Now you add up all these deviations. Sum of deviations from the mean. Find out how much it is. Sum of the deviations from the mean, if I simply add up, it is coming out to be 0. So that is one important property of the mean. Sum of the deviations of each of the observation from the mean is 0. I subtract the mean from each of the observations, and I sum up the means, I sum up the differences, it is going to be 0. So, which is also like sum of the positive deviations, sum of positive deviations should be equal to sum of negative deviations. Right? You can directly use this property everywhere. But try to understand, this is not the same as number of positive deviations need not be the same as number of negative deviation. We are only talking about sum being the same. It's not number, which means I can't say that 50% of the data is above the mean and 50% of the values are below the mean. That is not coming out. But the sum of the values above the mean and the sum of the deviations below the mean, they are going to be the same. Only that part is being coming out by the mean. So it nowhere talks about how much data is above the mean and how much data is below the mean. And mean is unique for every data set, right? And it can be applicable both for interval scale data as well as the ratio scale data. I should not apply the mean for nominal data or ordinal data. Right? Only if my data is having an interval scale or a ratio scale, only then I am going ahead and applying the mean. And mean as such is affected by what we call as outliers. Very different set of data from the rest. The data could be extremely high value, a couple of values could be extremely high, or a couple of values could be extremely low, which will affect the mean very badly. The mean gets pulled towards these outliers. If there are a couple of values which are very high compared to the rest of them, what we see is the mean gets highly attracted towards this high value. If the couple of values are extremely low compared to the other set of values, the mean tends to come very much lower, closer towards this side. So these are what are typically called as outliers. They are going to bias our calculations heavily. So we have to really handle them much effectively beforehand itself. Right. So these are some of the things regarding the arithmetic mean. Then I am trying to bring out the concept of the median, which is another measure of the location, or sometimes the same measures of location, we also call them as measures of central tendency, because we are trying to find out the centeredness of the data. So mean said center is nothing but sum of the observations by the total number of observations. Whereas the median is saying that the middle is like you first arrange the data in the ascending or the descending order, right? And after you have arranged it, just pull the middle value. After you have arranged or probably sorted the data in the ascending or in the descending order, just pull out the middle value, and that is what we are calling as the median. So here the focus is 50% of the data is above the median and 50% of the data is below the median approximately. So median is talking about the number of data elements which are above the median and below. Here there is no guarantee that sum of the positive deviations is need not be equal to sum of negative deviations. So the median is not focusing on sum, but median is focusing on the number. Number of values above the median should be more or less equal to the number of values below the median. Now here comes if there are odd number of observations. So let's say I have 1, 2, 3, 4, 5, 6, 7 are the numbers. So the median, they are arranged in the ascending order. The median is the middle value. So I'll simply say median is value is 4, which is exactly the middle in the sorted order of the numbers. But if I am having only 6 numbers, 1, 2, 3, 4, 5, 6, now I have 2 middles, right? So I can't have one single middle. So I'm taking the 2 middle numbers and I'm taking the mean of them, which means 3.5 in this case. So if the total number of observations is odd, I'll have one single middle and I'll just say that is the median. And otherwise, if I'm having even number of observations, then I'll have two middles. I'll take the arithmetic mean of the two middles and use that as the median. So again, I can do the same using Excel as well, wherein I can either first do the sorting. I can very well sort this data. Let me try this out. This entire data, we are going to data, we are doing the sorting. I want to sort it, let's say, in the ascending order of the Sensex returns, smallest to largest. Okay, so this is the data that is sorted in the ascending order of the Sensex returns. And now I can very well pick up the middle value, right? If you are saying there are 36 observations, so it's an even number of observations, right? I can't have one single middle. If you look at 7 number of observations which are odd, I can very well say n plus 1 by 2th observation, which is 7 plus 1 by 2, 8 by 2, fourth observation is the median. Similarly here, when I talk about 6, 6 plus 1 by 2th observation, which is 3.5th observation, is the median. So I'll take the third and fourth and take the average of the two, call it as the median. Here also, if there are 36 elements, then 36 by plus 1 by 2. 18.5th element happens to be my median. So I'll take, so this is my 18th, right? This is my 18th, this is my 19th. So somewhere the average of these two should become my median. If I'm doing the median here, it is nothing but the average of, right? This particular number 1.12% and 1.3%. So I'm talking about a simple summation of these two numbers and dividing it by 2. So again, the median in this mechanism is coming out to be around 1.21%. Probably this is one way, but this is not the effective way of doing it in Excel, right? So I don't want the sorting to happen in this way, which is completely in a disorder. So what I can do is I'll revert it back. I don't want this kind of a sorting. I'll go with the sorting on the months itself. But again, here the data will get distorted. So probably I'll finalize this as 1.21%, which we have computed earlier. But a better way to compute the median is we have a formula called median, equal to median, and I select this returns data. It itself internally virtually will sort the data and pick up the middle element accordingly, which is also coming out to be the same as 1.21%. So if I am using median as a measure, I am getting the center value is around 1.21%. If I am using the mean, it is coming out to 1.23%. And probably better speaking, the median is good for a ratio scale data. It is also good for interval scale data and even for ordinal data. Only for a nominal data, median has no meaning. Right? So that's the slight difference between the two. And another advantage is mean is very much affected by outliers, but median is not. Right? Even if I have one or two big outliers, they are not pulling the median towards them drastically, but they are pulling the mean towards them quite drastically. So the impact of the outliers on the mean is very, very high, but it is not the same case with respect to the median. So that's one more thing we have to be comfortable with, the measure of central tendency, which is median. Now, we'll shift our focus towards the third one, which is the mode. Generally, we talk about this as the observation that occurs with highest frequency, which is the most highly repeating kind of element. So wherever we have very few set of unique values, very few unique values, that is where, and they are more and more repeating, that is where mode will have a lot of meaning. But if the data is having a very few repeating values, every value is repeating hardly once or twice, like our data here. I don't have any value that is repeating. Right? I hardly have any value that is repeating. So the mode, whatever we compute, it hardly has any kind of practical significance. Right? So one way is we can compute a frequency distribution, right? The way of identifying the mode, we can do a frequency distribution for each of the observations, and depending on which observation comes out maximum number of times, whichever is having the highest kind of a graph, we'll say that highest kind of a bar, we say that that is the mode. Or otherwise, we do have a simple formula in Excel, mode dot single, which will give me, if at all there is any single mode. Let's look at it. The mode, I'll use the formula mode dot single on this particular data set, which is telling me it's not applicable because you hardly have any kind of repeating element here. Right? Generally, it is applicable where a set of values are repeating, But here none of the sets are repeating, that is where the mode is not applicable. So either we can use it probably by doing the rounding offs, right? The same thing, let's say I round it, rounded returns. Now let's look at it slightly differently. So when I'm saying rounded returns, where I'm rounding it, rounding the return, let's say to the 0th decimal, or probably rounding it. Oh, I can't round it here. Everything works out to be 0 itself. So I should round it to -2. Okay, even if I round it to -2, all are working out, or probably if I'm rounding it to, yeah, I have to round it to two decimals, 2 digits after the decimal point, right? I'll round it to two decimals up, 2 digits after the decimal point. So all of them, okay, there are a few 7%. So now when I compute the mode, let's say on the rounded stuff, there is some kind of a repetition that is coming out. Mode single, if I'm doing it on this data, I'm getting that 0 is the most repeated stuff. Right, probably I could see that 0 would be repeating more and more. I can do a frequency distribution. Now if I try finding out the frequency distribution for this data, which is rounded, right? So let's try out the frequency distribution. -7%, -6%. I'm trying to find out how many times each of them are occurring in the data. Right, let's say I am doing it up to 10%. I am trying to find out how many times each observation is coming in this entire data. Right, within this entire data, how many times each observation is coming. -7% has come out once. So this did not come out at all. These all came twice, whereas 3% came 4 times. Right, and 0% or we'll not use this formula, we'll use the formula frequency. So what we'll do is out of this entire, for this entire lot, let me use the formula called frequency. Within this entire data, I'll talk about these being my bins. I'll do a control shift enter. Okay, here things are better. So I'm getting a -7% occurring once, and these all are occurring twice. -5% to -1%. 0% is occurring 5 times. 1% is 1% and 2% are occurring thrice, whereas 3% is occurring 4 times. Which means the 0% is occurring the maximum number of times, and that is what is being given by the mode here. So where there are a few set of repeating values, mode will do the job. But if there are more set of repeating values, mode is of not much of use. And the same thing can be applied to a group data as well. The group that is having the highest frequency is what we are calling as the mode. So we should be able to compute the mode from the data. And in some data sets, there is a possibility that there are multiple modes, right? And in some data sets, there may not be any kind of a mode. As we have seen earlier, when there is no value that is repeating, there will not be any mode. when there are multiple values that are repeating equal number of times, there is a possibility of multiple modes also present in the data. So that's one more way of measuring the centeredness of the data. And coming to the fourth measure of central tendency, which we are calling as the mid-range, it is very simple. I take the lowest value and I take the highest value in the data, and I simply take the average of these two. That is what we are calling as the mid-range. So if there are very big outliers present in the data, they are completely distorting the result, right? Because I'm taking very extreme low value, extreme high value. Other values I'm completely ignoring. Only two pieces of data are being used. Whereas in case of the mean, though it is affected by the outliers, it's almost considering every value, right? But typically we use this as a measure when we have a small sample size, right? And to a large extent, we just require a quick rough estimate of the mean, right? On the spot, I just quickly want to look at what would be the approximate mean. In those kind of cases, I can take the highest value and the lowest value, and out of them compute the average, which is what will give me the mid range. So in this case, if I am looking at the mid range, I am first computing the minimum value. So for that, I require first the minimum value in the data, which I will find out using the min as a formula. Then I require the maximum value, which I'll compute using the max of the data as a formula. And then I can find out the mid range, which is the simple average of the min and the max. So I'm getting around 1.12%. So this is how we compute the mid-range, which is the average between the minimum and the maximum value, where I am ignoring all the other data elements altogether, right? So these are the four different forms of measures of location or measures of central tendency that we all need to be comfortable with, right?